this is a very important lecture because you do need to have the quadratic formula memorized. The quadratic formula allows us to solve equations of the form ax squared plus bx plus c equals 0. So when your equation is in standard form, as we have here in problem number 1, we need to be able to identify which numbers are in the A, B, and C position. And in this first case, there's an understood 1 in front, so A would equal 1, B is going to equal positive 5, and C is going to equal negative 2. If your equation is not set equal to 0, as is in this next problem, you want to first add the 4 to each side and have negative 3x squared plus the 7x plus 4 equals 0. And then you can identify that A is equal to negative 3, B is equal to positive 7, and C is now equal to positive 4, not the negative 4. Now I also want to comment, had we moved the x squared to the right side of the equation and set it equal to 0 on the left, the signs of A, B, and C would have all been the opposite of what I've got here, and that would be perfectly acceptable when it comes to using the quadratic formula. Now, let's talk about solving using the quadratic formula. First off, you've got to have it memorized. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there's lots of cute little ways of learning this formula. You can put it to the tune of Pop Goes the Weasel if you want. Let me do that for you. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Or there's a lot of little cute stories and stuff you can find on the internet. If you want to have some fun, go and YouTube the topic quadratic formula, and I'm sure you'll find a whole bunch of stuff to entertain yourself, but that would take away from your studies. Now, I do the quadratic formula or evaluate it a little bit different than most other students and teachers do. I do not substitute my values for A, B, and C directly into the formula. Instead, I find the value of b squared minus 4ac, the expression under the radical, first. It actually has a name called the discriminant, and I find that it actually serves quite a few purposes by evaluating it first. So b squared for us, we've got a is 3, b is 5, and c is negative 1. b squared becomes 5 squared minus 4 in the formula times a, which is 3, times c, which is negative 1. This becomes 25, and multiplying the 4ac together we get plus 12, and that gives us a total of 37. So the value of the discriminant is 37. Then I continue on the rest of my problem and I say x is equal to negative b plus or minus, and I write my formula out, but I substitute in the 37 that I've already found over 2a. And then I go straight to my answer. Now you might write an extra step in here, but I'm going to say x equals negative b. Now if b was 5, that gives us negative 5 plus or minus the square root of 37 all over 2a. If a is 3, 2 times 3 means it's all over 6. And there's our solution. This was not factorable. An alternate choice would have been to complete the square. We could have done that, but this also works. In a way, this makes the complete the square process obsolete. However, in your future math classes, there are going to be times where complete the square works and the quadratic formula won't. So this is you do need to know both procedures. Okay, moving on to another example using this quadratic formula. I'm going to begin with b squared minus 4ac. A is 4, B is 2, and C is negative 5. It's already written in standard form for me. So B squared is going to become 2 squared minus 4, that's in the formula, times the next 4, which is A, times negative 5. That becomes 2 squared is 4. The negative times negative becomes positive, and 16 times 5 is 80. So I'm going to have 84 for the value of the discriminant. And by the way, if this was a negative value, you'd know that we're about to get the square root of a negative, which gives you no real solutions. And that's one value or reason why sometimes you just want to do the value of the discriminant first. Now I'm going to move on and say x equals negative b plus or minus, and instead of writing b squared minus 40ac, I'm just going to write the 84, which I found, all over 2a. Now in this problem, 84 can be broken down. It's 4 times 21, and that 4, as you know, is a perfect square. So on this next line, x equals negative b, I'm going to have negative 2 plus or minus, I'm going to rewrite that root 84 as a 2 root 21, all over 2a, which is 2 times 4, which is 8. Now, this is where we get into trouble in terms of reducing answers. You cannot cancel the 2 and the 8 out front, nor the other 2 and the 8. Instead, as you know, you need to factor. And I'm only going to factor the 2 out, leaving negative 1 plus or minus 1 root 21. I only factor it out of the outside numbers. I leave the 21 inside, all over 8. And then, finally, the 2 and the 8 will reduce to 1/4, and we can write our combined solutions as negative 1 plus or minus the square root of 21 all over 4. Now let me highlight a couple of places where I found over my years of teaching students to make mistakes. The first place we make mistakes is with the plus sign right over here on the left. For some reason we just mess up with the signs, we accidentally add when we should subtract, or vice versa. The second place where people tend to make mistakes is with negative b. I plugged in a positive 2, but had b been a negative 2, we'd have negative of the negative, and that would have switched to a positive. So we've got to be careful with that. And the next main place where the mistakes occur is with this factoring and canceling. For some reason, that's just a skill we don't like to have or use.